السلام عليكم ورحمة الله in the name of Allah, the most gracious, the most merciful. Shabab, regarding this question 1, okay, in the exam, we have two straight vertical wires, X and Y. These are the two straight vertical wires, okay, X and Y, pass through holes in horizontal card. This is the horizontal card, and these are the two holes. One is X and the other is Y. Okay. Figure 8.1 shows the card viewed from the above. Okay. So we have, let's determine the directions here. Here we have three pairs of direction, if you remember. This is right, left. This is up, down. This is the pair of out, in. Okay, these are the three pairs of directions. So whenever we find currents, directions, currents, fields, and so on, we determine or remember these three pairs. Well, let's continue reading. This is a current. There is a current in each wire. So X has a current and Y has also a current. Okay, at in each wire, in a downward direction, it means into the page. Okay, so this is the direction of the current. It's in, because we said that in has the symbol of the back of the arrow. Okay, and out has the symbol of the front of the arrow. Well, so we have small cross here and another small cross here. Well, the first question says what? Says the magnetic field at Y due to the current in X produces a force on Y. So here we study Y. The magnetic field of X acts on the Y. So first of all, to find this magnetic field, let's remember we have three rules. Number one is the rule of the right hand gripping rule. Okay, this is the rule that's used here to determine the direction of the field. Okay, and left hand rule of Fleming and Fleming's right hand rule, they are not used here. Okay, so here we will put our thumb of the our right thumb inside the paper perpendicularly. Okay, and circle the remaining fingers. Okay, then they will give us this direction, the direction of the field. So the direction of the field is shown in this figure as I put them on the paper. So here, the direction of the field in the side of Y, the field that reaches Y is downward. Okay, so we will choose the downward. This is the field. Let's remember that the field is the first finger of which hand? Of the left hand, because we want to determine the direction of the force that's acting on the Y. Okay, and to determine the direction of the force, we use the Fleming's left hand rule. Well, so field first. Okay, well, the direction of the current, it's inside the paper. So this is the current, and we said that the current is the second finger. Okay, so by applying the left hand side of Fleming, we will get the direction of the force. Okay, and we will find that the thumb points in this direction, okay? So the direction of the thumb represents the direction of the movements or the direction of the magnetic force. Well, after that, let's go to the question to see what does it want. The question says, place a tick in each blank column in the table to indicate the direction of the magnetic field, this magnetic field, and the direction of the force. Well, let's see. Here, the magnetic of Y, we determined its direction. The magnetic field of Y, we determined its direction. Okay, it's directed downward. Okay, so it's towards the bottom of the page. Okay, so this is the first answer. Okay, what about the force on Y? It's to left. It's to left. Okay, so these are the correct answers of this question. Let's talk about this question because it's tricky. It's not tricky, it's easy, but you made, during your answers, you made some strange mistakes. Okay, especially Ahmed Rajab, it was strange from you because you're, mashallah, an excellent student. Okay, state, okay, tamam. State and explain whether there is also a force on the wire X. The question has only one mark, so it's dangerous because if it has two marks, the statement will have a mark and the explanation will have another mark. But here we have only one mark. So if you make any mistake in any of them, you will lose all the mark. Okay, let's see. Is there a force on the wire X? Yes. Okay, because of what? Because the wire X, it has electric current. So, excuse me, concentrate because this is a very important point. So, it has a magnetic field and the Y has current, so it has another magnetic field. So there is interaction between the two fields. Okay, remember the following statement well. The magnetic field happens as a result of the interaction between two magnetic fields, not between a magnetic field and an electric current, Ahmed. Okay, so please concentrate. Here, state and explain whether there is also a force. Yes, there is also a force. Yes, there is. في خلاص, we agreed together. Why? Because of the interaction between the magnetic field of Y with that of X. Or at least you can say because of the magnetic field of Y. But some students of you, okay, wrote that in his answer sheet, wrote because of the field of Y get cut by the field of X. Get Y get cut by the current. No, you have to give the perfect description. What's the idea about the current? Okay, the current doesn't make any sense with the field. The field interacts with the field. okay? And by the way, this is completely different from the electromagnetic induction, okay? When we are talking about the electromagnetic induction, we say get cut by the wire, even by the wire, not by the field, but by the current. It's very important, okay? Well, let's read the following question, because the following question is so tricky, and you approximately, many students made also strange mistakes because they didn't read the question well. Let's read. Figure A2 shows what I told you. When you are reading the question, you have to catch your pen and make circles or underline the keywords. If you do that, you will not make such strange mistake. You remember I said الشيطان يسكن before the figure. Do you remember? Okay, before the figure. These hidden lines before figures are so dangerous. Okay, so figure A2 shows DC supply. This is DC يا شباب. So how can you say in your answers as you did, because the alternating current gives alternating magnetic field. From where the alternating current came, there is no alternating current here. This is a direct current source. This is a direct current supply. You have to read the question carefully. You are excellent students. Don't make such strange mistakes. So the DC supply connected to the input of the transformer, okay? This is the transformer in front of you. This is the DC supply, and we know that the coil that's connected to the supply is called the primary coil, and the other that's connected to the output is called, or the load, or anything like this is called the secondary coil of the transformer, and this is the iron core. Okay, the question says when switch S is first closed. Once you close the switch S, this one, okay, the needle of the galvanometer deflects briefly. Be careful, briefly. It will not stay deflected. It will deflect for a short time, then returns to zero. The question, explain why the brief deflection occurs. Well, so here the most strange, I don't want to say stupid, the most strange mistake you can make is to say because the current produces alternating magnetic field. No, because there is no alternating current here. Okay, so what will the first step be? We have three marks here. The first step will be because the first step of the answer, because the sudden because the sudden or short or brief, let's use the word brief, change in current causes what? At switching S on, or due to switching N S on. This is makes what? Causes. Breathe. Change in magnetic field. Breathe. Change in magnetic field. هنا بقى that's transmitted أو cut, that's cut by the secondary coil. Okay, or I can say it gives a changing magnetic field to the electromagnet formed by the core, and it's transmitted to the secondary magnetic field. Finally, number 3, I have to say the famous statement that induced electromotive force or current for brief. This is the answer. Okay, well, these were my notes on your answers of the first question. طبعا alhamdulillah, we did these mistakes here when we are solving a mock exam. Okay, alhamdulillah, we didn't such mistakes in the real or the external exam. So say alhamdulillah, and you are a student, you are an excellent student. Okay, and these mistakes are for improve ourselves, not to say that we did bad or something like that. No, alhamdulillah rabbil alameen, you are excellent. Thank you very much. Assalamu alaikum wa rahmatullahi